Good morning, everyone. Welcome to Decoding Data Journey into the Discovery Phase. Today, we are talking about the discovery process for a data process. We'll touch on basically areas like gathering requirements, understanding the data source, understanding the architecture and design that we need to build in order to provide a solution. So this is a process-oriented approach where we actually touch not just about programming, but also about planning and process fundamentals. So let's get going. Welcome. My name is Oscar Garcia. I'm a principal engineer. My focus is on building solutions for data engineering and web engineering or applications on cloud technologies like Azure and Google GCP. So today my focus is on something that I like to share with a lot of my customers and a lot of my partners, which is to be able to talk about process, be able to actually talk about how to go about and start kick off a process or a project, right? Is instead of just going and start programming, what are the steps that we need to look at in order for us to deliver a solution, a successful solution. So please let me know if you're able to see the screen properly and you are able to see the fonts. If I need to increase or something like that, let me know on the chat. So let's get going. To start with, let's talk about what is data engineering, right? It's just most of us understand is something about data, building some database, building some data solution. But as a matter of fact, the data engineering is really a process, right? It's a process that involves several steps, right? And the whole purpose of that is to be able to understand the problem statement, the scope of work, the design and architecture for building out the solution. And this not only involves technology we're going to use, but also the approach, the delivery, the deployments, the code that we're going to use, the language like Python, C Sharp. What is it that we're doing that fits better for this project, right? So this enables us to build a solution that's going to provide an ongoing big data analysis for the business, right? Today's focus is on the discovery phase. We definitely have other sessions where we talk about the other areas. So stay with us and follow us to be able to give you more of that information later. Topics today is really the importance of the discovery process, setting the stage by talking about what technologies we need to use. We're going to talk about EDA, which is really the hands-on analysis of the solution of the data that we need to deal with to be able to build a solution. We're gonna talk about the importance of code-centric approach as opposed to using just visual tools, which are great as well, but we'll just talk about the details of the difference. Version control, which is a tool that we most use for our delivery process. And we are going to cover a real world use case to be able to get a really hands-on and understanding of what is it that we're talking about. All the materials here in the code is actually on GitHub. I put the link. You can see the link below. I also added the link to the chat and the Q&A sections. So please load it whenever you want, whenever you can, and just follow through. There's a lot of material there, not just for the discovery, but also for other phases of the project or of the process. So please give it a start. Increasing the I guess that repo, getting more stars is important for us to keep motivated and to keep building out more content for you guys. Why is important? Why is the discovery process important, right? Because it's really the step or the phase where we actually identify the problem. We take a look at the data sources and try to understand what the data looks like and what are the requirements around it. We establish the project scope. What is it? What are we building? Are we building a website, a database, a data warehouse, a data pipeline? And based on that, designing an effective architecture to address those challenges. So here, really, we're looking at clearly documenting the problem statement to understand what is it that we need to deliver. Make observations about the data. So we need to kind of understand where the data is coming from, where can we get it, what are the data sources, what is the structure to be able to understand how we're going to build a solution. Define the requirements based on the observations of that data, right? As you learn about the data, then we get to understand what we need to build and what requirements are needed. Clearly outline the scope of the project, right? Understanding what are we building, what is within scope and within the timelines, as opposed to just building anything out there, right? So we all understand that. And use the insights from the discovery phase to inform the solution. That means really the discovery phase is very important because it is a foundation for the implementation process, for the design process, implementation process, the delivery and test process, right? So it is very important to be able to build a solid foundation. And basically it enables us to build a project architecture that aligns with the requirements of the scope of work. Okay. So setting the stage, technology. Basically, as we go through the discovery process, we need to start making some decisions, right? We need to start planning and getting ideas of what we're building and what technologies are required for us to build the solution. In the case of our data engineering project, is often the case that technologies like Python as a programming language and with a set of libraries that to support data centric solutions is a very important decision. Your team may only have perhaps knowledge on other languages, maybe like C#, what have you, which you can also use, but there are some challenges with that. So Python is a good fit for that. So use cases for this is data download, cleaning, exploration, transformation, scripting, automation, anything that's data related. As you all know, with computer scientists, machine learning, and all those other projects, you can use Python. It's a very powerful language. With that comes something, Jupyter Notebooks. I don't know if you are familiar with that, but it's an interactive tool that we can use as opposed to like building code and kind of running it, compiling and running it, and what have you. Python notebooks, Jupyter Notebooks, we can use Python and actually create like a spreadsheet type environment. We're actually just adding snippets of code and executing them on a live notebook. So we can see immediate results, and it can help us go through a brainstorm process where we can actually see the code and see the data and understand everything that is going on. A tool that is powerful for this also, Visual Studio Code is a lightweight tool by Microsoft that enables us to get plugins for all these technologies, whether it's Jupyter Notebooks, Python, SQL queries, connect to databases and things like that. Visual Studio is incredible and integrates nicely with version control systems like GitHub, which is important for this process. Definitely SQL, because this is a data engineering process. Definitely SQL always is we're going to use it. We're going to end up using it for data analysis, for querying, for making sure things are looking the right way when we are ready to build some kind of reporting or visualizations. Exploratory data analysis, EDA. So this is really this is the method for going through the data, right? So as we build this process, we understand that one of the few questions we're going to ask is what's the data source? Where's the data coming from? What does the data look like, right? Often, there may be some data dictionaries, there may be documentation that provides a lot of information to help us get going, but most of the time, different companies and systems are lacking that level of detail. So we need to go and explore the data and understand it. And it's also a requirement for us to become experts on the data, because that's what we need to be able to understand it and be able to build a solution plan. Right. So during this process, we'll identify the data structure, the patterns, the relationships, the anomaly data, what's good data, what's bad data, what's junk, right? We use Python and Jupyter Notebook to enable us. That's our main tool, right? That's really our main tool to be able to go and start using those technologies to be able to query and build some analysis. We gain insights from the EDA for to document and be able to enable the analysis of the project to be able to understand, right? So once we start doing more data engineering tasks like implementation and design and architecture, this is based on what we learned. This is going to be a gate into those processes to be able to start gathering those requirements and that understanding. Another thing that enables us to accelerate and get there fast is when we use Jupyter Notebook, we're able to structure, if we're able to structure the code in such a way that we can export it, it enables, it can be used as a foundation for building out components, for building out data pipelines and transformation services. Code-centric approach. So you will see many, depending on the industry, depending on the company, right? A lot of this data analysis could be done using tools like perhaps Power BI, Looker, even Excel, right? There's a lot of companies that will use Excel to be able to look at the data and all that. But the code-centric approach really tells us that we could use a programming language and tools to be able to help us understand the coding methodology and for building the data structures and the schemas, right? And what this really means is that when you use a tool like Power BI, Looker, they're so powerful and they do so many things that they basically do their own data casting. They do um, they set up some data transformation for you. A lot of things are really hidden, and you can't really understand what's going on behind the scenes. But during the code, with a code-centric approach, you are able to establish and basically code all of that yourself and be able to understand and get a hands-on approach to the data, right? Understand how you will go about to do the transformation, right? So and with the help of Python, right, we can actually go um, and use pandas, NumPy, which are very, very robust and for data manipulation, where we can actually do transformation services, we can do mapping, we can do kinds of stuff to enable us to understand the data structure and be able to create a schemas for us moving forward to understand what we want the data to look like. Definitely for code with code-centric approach, we can do a sophisticated analysis, right? We can do aggregations, distributions. We can do all kinds of visualizations as well. Not meant for the public consumption, but meant for the analysis, right? That are actually doing the analysis, but they're really not for the quality is not for to display it as a dashboard for the company, for example, right? It's not. But we got to understand limitations as well. And yeah, definitely visual tools like Power BI are very powerful and all that. But like I mentioned before, they just don't give you the details of the data exploration, right? They don't give you what's going on behind the scenes. But with Code-centric, you're able to see it right away because you will see first, you will see how challenging it is to do certain transformation or maybe identify certain things that are being done in the data that you can suggest or provide feedback for the team to correct the data. As we move forward and we start building a solution, data engineering solution, definitely an area to focus on is version control, right? And tools like GitHub are effective tools, not just for version control of the code, but also for collaboration, for documentation, for automation, right? Automation in the sense of running test automation, running build automation, and actually deploying into different environments. So pairing it with version control tools like that is a powerful way to start a project. And this is something that you identify during the discovery phase, right? We definitely do centralized tracking for track issues or requirements as you start building out through the discovery phase. Then things that are needed, sharing definitely with the team sharing effort where different teams can leverage what the discovery scripts that some of the members have built, and it enables us to learn from that code that was generated as a foundation for other components. Very powerful for documentation, right? We can using Markdown, which is a sort of a HTML-like markup. You can build very powerful documentations as the one you see on the right side of your screen, and you can actually put pictures, links, um, and basically create a sort of a design layout for the documentation, right? And definitely project management, right? Project management to be able to um, create your tasks, your requirements, your facilitate deployments through CI/CD pipelines for the delivery automation of the solution. Okay, so we're gonna now take a look a little bit more in detail about the process. We cover the foundational concepts, but let's take a look at what that really means, right? So we looked at that the concept. So what does that really mean now? So let's take a look. Like right, we need to understand the problem statement. What are we building, right? So we need to clearly understand that. So in this real use case, the problem statement is that if you're familiar with the city of New York, they have a very advanced subway system, right? And through this subway system goes through the entire city, and for commuters to use the subways, they need to go through through gates, right? And what's happening is New York, excuse me, tracks this. The MTA system tracks this activity. So you can imagine a city like there are millions of people coming in and out of subway stations. They're tracking millions and millions of commuters per day. Right. So this has opened up an idea or a business opportunity where businesses would like to create the concept of a geofence. Geofence is really just a virtual area around a subway station, for example, right, where businesses that are within that perimeter would like to be able to target users, right? So, for example, if you're in Times Square and there are stores or restaurants in Times Square at a particular time, and you are coming out of the subway station, they want to target you, right? They want to say, "Oh, look, let's push a notification on advertisement and mess like this." So our challenge here is to sort of get that information from the MTA system, be able to have a solution that enables us to provide a legal way for businesses to be able to say, yes, me that my business in Times Square has a much better traffic at 11 a.m., for example, or whatever that is, right? So the analysis process will actually identify what those requirements for that business, so they can target the customers. They can send ads to that customer. So and basically the concept of the style, which is a gate that as you come in and you leave and you turn that turnstile, then you're recorded as an entry or as an exit, right? An entry meaning you're gonna ride the train, an exit meaning you're just getting off, right? So what we want to do here is, in the analytical approach for our discovery process, we're gonna use this data to investigate the stations with the high number of exits by day and hours, and the high number of entries by day and hours. So really here the analysis is, look at the commuters and let's look at peak hours for certain locations, right? Because the whole idea here is the geofence location for that, so that business can just target that particular geolocation. So you start thinking, right, during our analysis and discovery phase, we'll start thinking about, okay, we need to do locations, we need to do days and times and stations and what have you, right? So, but the end goal is to create an analysis that enables businesses to go and target and understand their traffic. And this, what you see here, is really a visualization that live is public. And there's the link is right here, and you can actually see what is going on, right? You can see the total exit entries, and you can actually filter by dates, you can filter by station name, and it gives you the time slices, right, by date and by a particular time range. And what we got to remember here, that this is a massive amount of information that it's kind of hard to target this solution on a transactional basis, right? So it doesn't help us to get 1 or 2 or 5 people. We just need to look at the bulk of the users or commuters within a particular time frame, right? So for that, we start looking at our discovery process, right? So the first thing we want to look at our discovery process is sort of understand that problem statement, right? So we kind of understand that. And by the way, this is the GitHub repo that I'm opening right now through Visual Studio Code. But everything is on GitHub. But I'm just giving you this look because I'm gonna run some of the discovery with you. So this is really the landing page. What you want to do here when you are playing around with this project is you want to go to step and open the discovery Jupyter Notebook, and you will see a lot of the code that has been written to be able to do some of this analysis. And also you can look at the README file, right? And this is what we call markdown syntax, right? So and we can do a preview of it as if we are loading a web page, right? And we look at the discovery process here. So here we can actually see where we can get the data. We have to do the analysis of where we can get the data, right? And we start making observations. I'm going to run you through the observations pretty quickly so we can then look at the code. So you get an idea, how do we get this data? How do we get this information? So as we go and do research as part of the discovery process, and we look at the MTA system, we look at the data. The data is only available on every Saturday or every Sunday. I think it was every Saturday. And we want to run this batch process maybe on a Sunday, for example, right? And we notice that the audit of this information is so massive, it's being done every 4 hours, right? So 4 hours, they're slicing the data, but they're not giving it in any other form, right? So they're not really going down to the minutes because it's too many transactions for them to do that. So they do aggregations. So that's the one thing that we start analyzing. We start thinking, okay, so they do aggregations. What are the I guess the dependencies or limitations of the data if they're doing it by 4 hours, right? So those are things that we need to document on the discovery phase. We look at the data. Data is separated into day and time, right? We may not want to do that. Maybe we want to consolidate the data because it doesn't make any sense for us to have it like that. I'm gonna blow this up a little bit. Right. So we may not want to do that. So we start looking at the data. We start kind of identifying what's going on here, right? We in the data dictionary to gather information and see what we're talking about, right? So we can kind of document that and see things like, for example, there's this CA control area that has a special character with it. So we need to be aware of that and be able to say, look, so below this data, there's a special character there. Perhaps we need to do some transformation here to facilitate the data without any problems, right? And we look at the fields, units, and we understand what they mean, right? As station, and we start gathering information. Station is a key field here that will give us GPS location, right? So station location will give us coordinates where we can actually identify and build a geolocation around it. So that's very important. That's a very important field. And on top of that, definitely the day and time are very important because that gives us, if it's Monday or Wednesday, what day is busy and what time frame of that day you see the most people around that geolocation. Like entries and exits, which are the measures, right? The amount of people that are actually going through the gates. So as an example, and this is coming, actually, this information you see here is documentation that's coming from our discovery process and analysis that we have to do through code, right? So, and we'll look at that also in detail. But here is exactly what we're doing, is looking at the data, sampling the data, kind of understanding and running some conclusions, right? We have to merge this these two fields into one called created, which is a daytime. The station is an important dimension. It's a location for dimension. The entries, the exits, exactly. And then we can say that we can identify a gate by using the control, the SCP, and the unit columns. So because what that means is station can have 30 gates, right? So that's how they are actually identified, which is important because that way it enables us to see what gate has the most number, which is really not relevant for our project problem statement, but it's just really part of the thinking process, right? And then we definitely start writing requirements, right? We need to start figuring out, okay, based on the batch requirement we have, we need to take it from there and start defining our infrastructure requirements. How are we going to do this, right? How are we going to automate the process of building out? What do we need, right? So we're going to need is definitely, for example, VMs for a process to run, data lakes for our batch of data to be uploaded, data warehouse system for us to host the data for analytical purposes. But then how do we do this? Do we go and click on a web page, or do we automate the process using the form, right? And so, and excuse me if some of this technology is not familiar with, but this is like the cloud native type approach. So you build out Terraform scripts, which really will help you automate the build out of resources on any cloud provider, Azure, AWS, Google, and so on. We define the orchestration process, right? So as part of the process of building out the requirements, we need to understand how do we support it, right, for operational requirements. So we need to start building out, when we start building out a solution, we need to think about how do we do orchestration? How do we schedule this? How do we monitor this? How do we recover from errors, and so on, right? Build out the structure of the files, comma delimited files, separated value files into the data lake. How do we build, once we have, how are we going to build our data warehouse? How are we going to structure that? How are we going to optimize the model, right? And part of the analysis was to discover the measures and the dimensions that that data source has. So basically leads us into now what is the schema model into our data warehouse, right? When we start building that star schema, what are we doing? How are we building it? Do we build dimension tables for station and for gate and so on, right? It gets into that level of detail. And then when we create a data analysis dashboard, what technology are we using for? So this goes into more of what aligns with the industry, with the company, right? Do they have Power BI? Do they have Looker? And if they don't have it, cannot do the analysis for them to be able to for example, if they're Azure Cloud, maybe they Power BI is a better. If they're a Google Cloud, maybe it's better for them, and so on, right? So we need to go through that analysis and think about that. Identify the time slots, right? Morning was afternoon. What are we talking about from 5 to 7? Or are we talking about from 7 to 9? What are the time slices, right? What are we really looking at that makes more sense? Look at the distribution by stations, and basically define the data models for us to be able to build this out. So as you continue to read these, then this gives us instructions on how to run this, right? Through code, right? Through Python. And if you want to run it through Jupyter Notebook, you can do that. So it gives us this kind of level of detail. But with that, and it gives you an example of what you want to do. But let's take a look at really more of a discovery process to do. Okay, so this is really the exercise, right? The exercise here is, give me a minute to see if any questions. Hello, okay. So you can use the QA if you have any questions, right? So the Discovery Jupyter Notebook, really, this is loaded on Visual Studio Code, if you have not noticed. And the way this works, if you install the component or the libraries that can run on Visual Studio Code, you will actually install Jupyter Notebooks engine within Visual Studio Code. And as it detects a file with the IPYNB, which means Interactive Python Notebook extension, it will be able to load that that library for us. And you will see that as you load it, the first thing you need to do is you need to connect to a kernel, right? And you see Python 3.8 here. So that's the kernel that's supporting the execution of this, right? Now, moving on to the coding approach. To the coding, just like if you're doing a Python file or a C# file, you need to import the libraries, right? You need to understand what libraries to import. And usually for data analysis purpose, things like, for example, pandas is key, right? Pandas is important, right? And as you will see here, as we import this, the way to run is you can click on that little triangle here, the execution button, or you can just do Control Enter, and then it will run that cell, right? So this cell gets executed right there. All the libraries and dependencies are loaded, and you are off and running. You can download a file using wget. This is a Linux-based implementation. And you can do that. I'm not going to do that because that's going to take a few minutes to download 32 megs of data, but I already downloaded this for the presentation. But this gives you an idea how to do that, right? And you can just run it like that, or you can use a full-blown script, as we can have here in the discovery Python file, and you will see more how to actually do that through code, right? And this is kind of the code that will run through a data pipeline, right? This is the code that will actually run a pipeline that actually, instead of just doing a wget, it will actually do it will read a CSV file from the internet, from a URL, use an iterator to do a chunk size download of 10K, for example, right? So this means it will just, instead of downloading the whole thing, it will just stream the data in chunks and download it. So this is a more efficient way to avoid timeouts and issues like that. But this is the interactive way. And what that means, this is really the way for us to quickly do things, right? Because we don't know, right? We're not really building code right now, a lot of code right now, because we barely know what's going on. We just want to know, what does this data looks like? So you download that data and you go into the EDA, right? And the first thing you will do is, okay, let me read that file that I downloaded and let me understand what's in it, right? So you will go ahead and run this. And again, you will just do Control Enter or execute a cell, and it will just run it. And it will actually tell you the data frame looks like, right? And what that tells you is that, okay, so this is what we see. We see 253,000 entries. So you can see the file has a lot of data. And it has all these different fields, right? And they're all in capital letters. CA has a special character in there, right? So you start making those observations. You start documenting those observations, maybe because for your coding standards, maybe you want to just do small letters, right? Maybe you don't want all caps. So it really depends. You start applying your coding standards in this process as well. So you document, this is the kind of format that it has. As you can see, most of it is objects, which means they're really strings, and it has identified the entries and exits are integers, right? They're numeric fields. So we identified that those are the entries and the exits are really our measures, right? The units that we can count, that can aggregate and create totals, right? So we go and do analysis with columns of the data or the names of the columns, right? We want to what has a special characters, and we start scripting some of the stuff, so we're able to pick up, hey, what do we want to reject from column names, right? And we can script and be able to do analysis, and then we can see that we pick up the CA has a special character. So we want to do is we want to rename this, right? So we run this rename columns function that basically what it does is says, if I find a column name with special characters, I want to create a mapping to map it from name A to name B and rename it. And the way you will see is here that C/A is mapped to CA, and so on. So this is handling mapping for you. And then we do an info, right? And this is part of the whole exploratory analysis, right? That we're actually learning from the data. This is really part of that process, but more in the implementation phase now. So we're being more code-centric and be able to understand this. So we see that this works, right? And we're doing the analysis and we're coding and we're actually using this to build out our documentation. That's really the key, right? That this is building out our documentation. So we can see, okay, so now we took care of the column name. So this is great. Of course, we got to do cleaning. We got to find out if there are null values in a particular column, and we got to do the analysis. And if there are null values, you got to make some decisions, right? So if you have null values, maybe you want to drop the null values, or you want to from the record set, from the data frame, or you want to just fill them out with 0. So this is kind of part of that analysis, right? Does it make sense for us to have, for example, records that have null for entries and exits, for example? They should be 0, because in fact that's nothing, right? A null is nothing, so you can do 0. But if the station has a null value, then that is an unknown station and may not add any value. It's just really more of a feedback to the system of record and say, look, why are we getting stations with null values? There's a problem in your data feed. Can you help us with that? So we explore the data, right? So if you're familiar with Python and Pandas, really a data for, so Pandas support data frames, which is really more of a data structure. And after we load it, we can actually apply some operations on that data. One of them is head, right? Head is really saying, give me the top 5 records. And then we can kind of look at that and say, okay, so these are the top 5 records. And we start looking at this information and we start thinking, oh, okay. So we see, that we have a unit, a control, a CA, control access unit, a station, the line name, and we see that there's the day and time, right? We see the day and time is separated, right? And we start understanding that, hey, we see a window between midnight, right? And between 4 a.m. and 8 a.m. and 8 a.m. and 12 p.m. And then we see that 4-hour interval. There's a 4-hour gap in this data. And we can start looking at that and kind of notice that that's what's happening here. So one of the things that we can do is say, look, for us, it doesn't work to have day and time. It's just really not. It just gives us more work. We really want to have a day and time data point, data value. So let's do that. So, and we convert, we merge both the day and time. We give it a format. And in that format, then we're saying, hey, just give me a new field called created. And then we're going to drop this day and time columns because we already consolidated them. And then we can just show the data. So now we have something called a new column called created that has all the data that we need in one place. Okay. So this is part of that transformation process. Just start identifying all of this because this is what's done during the implementation phase, right? And then we can kind of look at it and look at the data again and see what's happening during transformation. And we'll see that as we do this, we see that the created, it's already built as a daytime, right? And we see that our entries and exits are integers. So we are good there because we understand those are the correct data types for those data points. But don't trust that, right? You have to do the analysis to make sure entries and exits is a comma separated file. So it may have empty values, right? It may have spaces, and you need to clean that up and make sure that the data type is correct. Then we start getting an idea what does the data really look like, right? What are we looking at? And then we kind of look at the stations, and we can see unique stations. And we start looking at it, and we see we're not talking about 5 stations, right? We're talking about a lot of stations, right? So this gives us some insight into the data to be able to understand that there's a lot of data here, right? We're talking about big data use case where we have a lot of stations and we have millions and millions of people coming through gates every 10 minutes, right? So this is a big data scenario where we need to kind of understand all those details, right? And we start making observations, right, as part of the document. Like I said, this is a markdown. If you double click on this cell, this is the markdown syntax. As you run that cell, it just renders the data like that. Okay. So it's a very important, very good way to document your projects and build them and publish them to things like GitHub or other repos where you can actually manage all of your documentations. Also, for example, this is a case I was talking about. So maybe all of our columns, have empty spaces, and that's not something we want. So for example, in the use case of our measures, we want to be able to make sure that we clean our we strip them from spaces and we cast them to the type we want, right? So we want to make sure that we cast them as we noticed before. It automatically infer that information, but in some cases it will not be able because it finds a space. So you need to clean it up, and then you need to explicitly say transform this type or cast it to this type, right? And then we start looking at data analysis. Now, let's make sense. We understand the problem statement. Problem statement is we need to build this out based on geolocation. So we start looking at, okay, let's look at the data by station and create it. And we see the measures, right? We see the total of entries, total of X's, and we can start playing around with the data. Let's group them by station only, and we start seeing the totals. We can by stations, and we can see they're huge numbers, right? And this is just one file, right? So the whole purpose of what I'm going through right now is to show you the capabilities of Python and pandas and the tools, and go through a process of looking at the data, right? Looking at the data, having an idea, and at the same time documenting it, because this is really generating documentation on the fly for us, right? And then we start looking at what are the time slots, right? We eyeball and we saw there was an 8-hour gap, but 4-hour gap between entries. But is that true? Let's look at that and see. And we see the unique hours, right? And that it may not be true all the time. There may be some gaps there that are really in 4 hours. So that's something for us to explore a little bit more instead of understand it, because based on that, we'll write requirements on when to show data. And then, we have to establish requirements of what are the visualization requirements for really, what are we presenting? How are we doing this, right? So when we build a dashboard, we understand the direction, right? So we need to start looking at some kind of libraries for visualization and actually start building some, right? So we can probably start with a distribution analysis, right? And see what's the station the busiest and things like that. And we can use some libraries like Plotly. There's a Python library that enables us to plug in a data frame, and we can tell it, hey, use these fields to be able to build a pie chart, right? And we can start seeing that. And this could be your beginning of your requirements for a more professional visualization, right? And when it comes to that time of building out the dashboard, we go in and we start show the data by day of the week. So we know that time frame, our created day is really just a date, right? It's 12, 13, 23, for example. But we want to go down and analyze it based on the category of the day name, right? So we want to see what's the data on Monday, Tuesday, Wednesday. So we need to create categories in our data and create those additional sort of computed columns. So we're able to know that that particular day was Monday or Tuesday, and we can do analysis based on that. Right. And we can now say, okay, what are the statistics now based on that, based on date? And we can see, right? So we can actually, maybe this is something useful, maybe it's not. Maybe the data looks so the same, but there are people that are taking the subway, they're exiting the subway. So the traffic always balances out based on just a day. What's important here is that maybe the location is completely different because there are more people traveling at that location than others. But the important thing is that we're documenting this so people are not guessing down the process, downstream in the process. The people are not guessing, and we understood that somebody took a look at that. Same with the hours, right? So the hours is maybe we want to identify a time slot, morning, afternoon, night, and maybe these are the time frames from 8 to 11 a.m., right? Something like that. That we have to figure out, we have to define, but this is how the thinking process goes, right? We want to do analysis, right? We want to say, hey, look, so now let's look at this data. Let's fit our data points using the hour and fit them into a time slot, right? And that's where we build these arrays to build these entries based on that time. And then we can actually run some analysis and say, look, our averages based on morning arrivals and departures and afternoon and night and so on, right? And we can start looking at it and visualize the data a little bit more and kind of track it and see and start learning more and more and more about the data. And ideally, this all of this will eventually just lead us into building out all this documentation, all these requirements, the need for us to make our deployments in deploying our code, since we're using a code-centric approach. We're going to build code and how we're going to deploy it. We're going to use Docker containers. How are we going to automate those deployments to Docker in Docker containers? And think along all those lines and understand all that process is the intent and purpose of the discovery phase of a data engineering process. With that, we come to a conclusion. I want to thank you. If you have any questions, we have a couple of minutes. Please. So it is, I have a question here. So is it common for data engineer to be required to do analysis as well? And I will say a lot of the answers for that will be yes. So in a lot of industries, you have what's called a specialized people, right? Specialized people are actually people that would just code. For example, you will get requirements, you will get the requirements that we have in front of you, and then your sole job is to do the code. And another person will be responsible for building Docker containers and deploy them. Another person will be responsible for monitoring and testing. Those are specialized roles. I believe that it is important for data engineer to basically understand the process associated with it, right? To understand the analysis process. How do I build containers? How do I deploy them? And have that solid understanding of how that works. So my goal here with this series is to be able to tell everybody, developers, engineers, that the data engineering is not just coding, but actually understanding all the fundamental pieces around it. So for example, if you're not familiar with Docker, it's important for you to be familiar with Docker and how that impacts your deployments, how you're going to go about it, right? So it's really just to make the person, the professional, well-rounded. But in many companies, they like to look at specialized people and just let them focus on one particular area only. I'm not in that philosophy. I'm more of, my intent here is to show us that we have fundamentally, we're solid in all the areas, and perhaps we're not going to do a lot of the deployments ourselves, but at least we understand that if I'm writing code, I know how to build that in a container, right? And I know how that is going to look like once I push it to my environments. I hope that answers your question. So remember that. So I have another question. What is the last chart saying? We have more departures than arrival. Average count of passengers. Why will they differ? So, which is a good question, right? So usually everybody will say, hey, let's leave a particular morning, and doesn't matter where you're leaving from and where you're arriving. Everybody is leaving and arriving at a particular time, but there could be the gaps in the time. And this is a good question because this opens up more analysis. Hey, why does it look like that? Should I have even data? Right. And but there could be a gap here in the time slot. So basically, as we pick up data from a particular slide of time, it may be there's a gap there. But yeah, definitely I agree with you. In the morning, ideally, we should have everybody the same. But if people are departing at, I don't know, 9 o'clock, and they're arriving, and that departure made you arrive at 10 o'clock, which is the next gap, then that could be what's causing that. But it's important to notice that. It's important to understand the answer to that. Thank you. Good questions. Good questions. Just a couple of cleanup feedback here, guys. Thank you. Thank you so much for your time. Just keep looking at this. You can play with the live dashboard. Is there, get an understanding of the project, keep analyzing it. Please give it a star, and keep following us on the on the group. We have scheduled for next month, in 2 weeks, the what's called I guess design and planning, which is really where we start talking about the details of the data, that how we're going to build the solution, right? How we're going to build it with data lakes, data warehouse, terraforming, and all those things. So stay with us, and please, yes, and you can play with Jupyter all you want. This is more of a production quality. What you see in front of you is production quality dashboard, but the idea is for you to play with Jupyter all you want and get an understanding, and then think about how you can export that to be able to create your file. So if you look at it here from this Jupyter notebook, I can export my file here and have now a Py file that I can modify to my needs. Well, I think we went over a few minutes, but thank you everyone. Hey, follow us. We have more presentations coming along, so thank you for your time, and please give us feedback, and watch out for the emails and just give feedback, because that's important for us to keep doing what we're doing. Thank you everyone. Have a good day.